Aircraft structural members are designed to carry a load or to resist stress. In designing an aircraft, every square inch of wing and fuselage, every rib, spar, and even each metal fitting must be considered in relation to the physical characteristics of the material of which it is made. Every part of the aircraft must be planned to carry the load to be imposed upon it. The determination of such loads is called stress analysis. Although planning the design is not the function of the aircraft technician, it is, nevertheless, important that the technician understand and appreciate the stresses involved in order to avoid changes in the original design through improper repairs. The term stress is often used interchangeably with the word strain. While related, they are not the same thing. External loads or forces cause stress. Stress is a material's internal resistance, or counterforce, that opposes deformation. The degree of deformation of a material is strain. When a material is subjected to a load or force, that material is deformed, regardless of how strong the material is or how light the load is. Tension is the stress that resists a force that tends to pull something apart. The engine pulls the aircraft forward, but air resistance tries to hold it back. The result is tension, which stretches the aircraft. The tensile strength of a material is measured in pounds per square inch, SI, and is calculated by dividing the load, in pounds, required to pull the material apart by its cross-sectional area, in square inches. Compression is the stress that resists a crushing force. The compressive strength of a material is also measured in SI. Compression is the stress that tends to shorten or squeeze aircraft parts. Torsion is the stress that produces twisting. While moving the aircraft forward, the engine also tends to twist it to one side, but other aircraft components hold it on course. Thus, torsion is created. The torsion strength of a material is its resistance to twisting or torque. Shear is the stress that resists the force tending to cause one layer of a material to slide over an adjacent layer. Two riveted plates in tension subject the rivets to a shearing force. Usually, the shearing strength of a material is either equal to or less than its tensile or compressive strength. Aircraft parts, especially screws, bolts, and rivets, are often subject to a shearing force. Bending stress is a combination of compression and tension. The rod end has been shortened, compressed, on the inside of the bend and stretched on the outside of the bend. A single member of the structure may be subjected to a combination of stresses. In most cases, the structural members are designed to carry end loads rather than side loads. They are designed to be subjected to tension or compression rather than bending. Hoop stress is the stress on the airframe structural components caused by pressurization. All transport category aircraft are pressurized. A circumferential load is experienced in hoop stress. The structural fuselage framework resists this load with the aid of the stressed skin. Note that axial loads in the fuselage are also partially resisted by the stressed skin construction as well as the longitudinal structural members such as longeons and stringers. Metal fatigue is experienced by a component or structural member when a load is repeatedly applied and released or applied and reversed. This cycling weakens the material over time even though the load applied may be well below that which causes damage in a single application. All materials have an elastic limit. If applied loads do not exceed this limit, the material should be unaffected by the load and returns to its original state when the load is removed. However, an aircraft in flight constantly experiences varying loads. Over time, these small load changes cause fatigue in the form of minute cracks in the metal structure. Each tiny, seemingly inconsequential crack exposes new material to the elements. This may weaken the material through corrosion.